Okay, I think most of us are here. Welcome again to today's webinar. So the topic today is creating 3D models with a mobile mapping device. So with you again is me, Vit Peterman from 3D Survey, where we have worked on more than 500 photogrammetry projects. Today we have an interesting device that we had here on testing. So it's a mobile mapping solution. We will make a quick introduction of the device, show you what kind of hardware it is made of. We will show you the workflow for processing this data from this device, and we'll make a quick analysis of the results. So we'll have a look at what kind of results we get with different surroundings and what kind of accuracy we can expect from it. And in the end, there will be again a Q&A session where you will have the chance to ask any questions you might get during the presentation, or even if anything in general about 3D survey. Let's go right into it. So the hardware in question is the mobile mapping solution, which can be mounted on a car. So with this device, we can drive around, and while we are driving, it is taking pictures. So inside, if we look at it more closely, inside there are two cameras. Both of these are high quality metric cameras, which can take a picture every few meters. So the device also has an RTK GPS attached to it and an INS instrument. So we have two cameras, RTK GPS and INS. So INS, this means inertial navigation system. So this means device for measuring acceleration and rotation. And this one works together with the RTK GPS to provide position even when we lose the GPS solution. So with the device comes also a computer for controlling it and for saving the images. And now we can go ahead and look at the workflow for processing this kind of data in 3D survey. So when we develop 3D survey, we try to make it so that it can fit any camera and any data. So we tested it with this device, and also if we have this kind of terrestrial images, it turns out we can process them also in 3D survey. So now I'll just go here. I have here a new empty project. So this time we will go here and we will try to load in some images from a mobile mapping system. Just select all of them and press open. So here we will just use estimate automatically for the camera details. And now, because this system has the telemetry information, so that's information where the images were recorded from, this data will be in an external file. So we will select it here. And now we'll just set the data import. So just set image name, easting, so in this case we have here longitude, latitude, altitude, yaw pitch roll, pitch roll, and horizontal and vertical accuracies. Just like normal, we will also set up our coordinate system, and we will also apply a geoid model to the ellipsoidal heights so that we get our local orthometric heights. Just, well, let's find it. Here it is. Import. Perfect. So for this first test, we made this loop around our offices. So the total length here is approximately 200 by 100 meters. So all in all, we have around 600-meter loop. Now the processing would be just the same as it is in case of drone data. So we would go again to bundle adjustment. We can do orientation with ground control points, or we can even skip orientation with ground control points and just do the orientation with telemetry. So this is what we did in this case. We just used telemetry to orientate the data because in this case we are mapping from a closer distance. So with the ground control points would probably increase the end accuracy, but even with this solution, the accuracy seems good enough. So without using the ground control points. And then we would continue with reconstruction. So here we have a little under 400 images. So the images have 12 megapixels. So the processing would probably take, I don't know, around two hours, 2 hours and a half, something like that. Just so that we don't wait, I will just go here again and I will open a project that I have pre-calculated. So here again we have the images. So the left image recorded from our car and the right image. And after a few hours of processing, this was the result that we received. Let's zoom in slightly. So in this case, when we have this kind of data, actually the free flight navigation option works pretty well. So in this case, what we do, I just use the keyboard W, C, A, and D keys on the keyboard to move around our 3D model. So, okay, so here we didn't go this way. Our flying path went here. Let's speed it up a little bit. Maybe slow down a little bit. So what we focused a lot on, it actually turns out in case of this kind of data, the curves can be observed pretty well. So, you know, now a lot of LiDAR sensors are becoming available. So interesting about this one is the quality of the point cloud you can receive from photogrammetry will still be a lot better than in case of lower cost LiDAR sensors. Of course, with photogrammetry, if you have images of a car, here you get slightly less accurate points because, you know, we have different glare and gloss on the car surface. So, of course, because we are lens surveyors, the main question for us in our testing was what kind of accuracy can we expect from this system. So because of that, we went out and we measured some checkpoints. So these points we measured with a GPS instrument. So I would say the accuracy of these points that we measured would be approximately 2 centimeters or something like that. So what can we do now here? We can just let's just make a new layer. So here you can already see the point that I measured with the GPS, and this was this point here in our point cloud. So what will we do now? We'll go simply here to cat. I'll just name this layer measurements. Use red color so that it will display better, and I just want to measure 2D and delta height distance. So we'll just go here. First need to make this layer the active one, like that, so that we'll be able to read the text. Now let's measure like that without the 3D distance. So let's measure this one again. So here we get approximately 3 centimeters in XY and 4 centimeters in altitude. So I already measured all of these points on this data set. Approximate accuracy of this data will, here in this case, it came to around 5 centimeters. So we were kind of hoping to get the accuracy to around 4 centimeters. So what we were able to get here was approximately 5. So this one is also about 4 centimeters. It turns out also that all the vectors will be in the same direction. So for this data set, all of the checkpoints that we'll make will be around 4 to 5 centimeters. Let's have a closer look at some other checkpoints. So here we have another manhole cover. So let's measure this distance. From here to, let's say, here. So this one, here we have a horizontal 5 centimeters and vertical 3 centimeters. Move around. Again, let's make the measurement. So this one is maybe a little bit hard to see, but here the altitude fits better, but the position, it's also around, it was around 5, wait. Okay, here we have an interesting example. So I measured the top of the curve here and the bottom of the curve. So we can check the accuracy here. So very often when we are surveying, we measure the curves with 2 points, one on the top and one on the bottom. Let's see what kind of accuracy we get for this one. So here the horizontal accuracy will be, it's hard to know exactly where I clicked, but it's about 3 centimeters, and this one, this one comes to around 2 centimeters. And so this will be the values we'll be getting all around of our area of interest. Zoom in here. I measured this crack in the pavement. hard to say exactly where I measured it with the GPS. Probably it was a little more to this direction. So, but again, we see we have about 5 centimeter accuracy, around 4 to 5 accuracy in the vertical direction and a few centimeters in horizontal one. So it's like that. It's not that bad. It's sort of okay. It would be interesting if we could get to even better accuracy, but this already is something. Now, of course, for this data set, I also flew it with a drone, so we can directly compare some drone photogrammetry to road mapping photogrammetry. So let's go here to the point cloud. Let's decrease slightly the point size. And I just turned on the drone images. So the drone point cloud. So from far, of course, the drone point cloud looks a lot better because with it, we cover a lot more area. So when we zoom in closely, we see that in case of fine details, it really helps a lot if we have images from closer. So this is what the road mapping data provided us. This is what the drone mapping provided us. So here we know this effect when we have the curbs, because the curb can hardly be seen in drone images, it will get generalized slightly. So let's make this one blue. Checkpoints, we need to make checkpoint blue. Maybe slightly. So the height will be okay, but you know it's the height of the top of the pavement here, and the bottom height will also be okay, but because of this generation, you know, you should take the height from this area here. But combination, of course, will work best. Of course, these were recorded on another day. But the detail here will be a lot clearer. Now, one interesting thing we can get from this road mapping data, the X-ray function also works quite nicely on this one. So for X-ray, you just select here X-ray, set the resolution to around 2 centimeters, select whether you want transparent background or not, and in just a few seconds, you would get this kind of X-ray image. So funnily enough, on the X-ray, you know, those manhole covers that we were checking out earlier, they can also almost be seen now in the X-ray. So this here is the curb. So this is the fence, and we get some also some objects. So again, if we were making a survey map, probably you could get some data from here, or we could use this data in combination with point cloud when we would be making a survey map of our area. So here I have the slightly differently calculated X-ray. So this is with point cloud also enabled. And so here we can see the curves and where would be the best place to take to draw the curve line. Okay. So this was the first example. Now I'd just like to go through a few more examples that we mapped. So this one was the most perfect one. So the images we recorded in cloudy weather. It actually turns out that this is the best weather for this kind of data. Now I have here also some projects that we mapped with the same system. These ones will be in a sunny weather, and let's just have a look at them. So here on this one, we tried to do a similar thing, but this time, so again, we were checking the accuracy of this data, but this time we went into a city center where we have higher buildings. So in this data set, we were testing how the RTK GPS on this device works. So we found that if we drive along the route here along high buildings for a while, we will lose the GPS signal. When we lost the GPS signal, then in that case, the accuracy of the RTK solution, it fell to around half a meter. But for areas where we had good accuracy, this so in this case, the height difference between the checkpoints and the points in our model was again almost exactly 5 centimeters. So because of that, we are not 100% certain. So maybe just this device, they need to change slightly the position of the point they are taking. But most of the time, when we checked our accuracy with checkpoints, every time we would see the difference of around 5 centimeters or something like that. Let's have a look at some other examples. So for this one, we tried, so here we had a lot of the sky in our model, and here we tried to map a wider area and see how much left and right do we get in our resulting model. You will notice these funny looking cars. That's because the car was moving forward, so you can get this kind of artifacts in our data. But as far as the road surface is concerned, so here if we turn on the cameras, this is where we were driving with the car. Let's increase the point size slightly. You will also be able to get some details on the other side of the road, but of course it won't be as sharp as on the side you are driving on. Similarly, here we went to an area where we have a narrower street. Again, in the sunny weather, so we have some sky in our point cloud. Here we took a turn and went into this direction, and we continued down the street. So what's interesting about this one is with this mapping technique, we were able to drive around 40, 50 kilometers per hour. The producer of this device says that the top speed could be around 90, but we didn't try going that fast. I think this device is can be pretty interesting if we need to use it to map objects like roads that are longer than 2 kilometers, 3, 4, 5, something. Or if you have a big project where you will be mapping hundreds of kilometers of road. I think it can be also very interesting, you know, for some applications where you would be making where you would be searching for traffic signs and making a cadastre of traffic signs and these kinds of things. So the only thing we find it's probably not suitable for yet is for the projects where we are measuring the height of the asphalt. If you need this point exactly, you will still probably need to measure it with a total station. But other than that, it comes out pretty nicely. Okay. Now, okay. At this point, I would like to ask you for some input. So now we made a short analysis of this technology. Now I would just like to ask you two questions. So first one, I want to ask you, how did you learn about this webinar? So whether the information about this came through email, web page, Facebook, or something else. Okay, I see that most people have answered the question. So we have right now the latest results are, okay. So the latest results are 47% of you answered through email, 17% through web page, 4% through Facebook, and the other 4% selected other. Okay, thank you for these answers. I will just now click share the results like that. Now, the second question that I have for you is, how often do you measure roads longer than, for example, 3 kilometers? So the poll should come onto your screen in a few seconds. Okay, we will now slowly close the poll. I think most of you have voted by now, so we'll just press here close, share the results. So 34% of you less than once per year, 1 in 5 twice per year, a little under than 1 in 5 times per year, and 17% more than 5 times per year. Okay, that's interesting to know. So I guess we selected a good question because we get all kinds of answers. So we think for those that measure this maybe more than 5 times per year, roads longer than 3 kilometers, maybe this technology would be something that you could use. Now let's go back to our presentation, and now for the final part of this webinar, let's have a look at if we have any questions in the question box. So right now we don't have any questions yet. If anyone has any question about this technology, now would be the best time to ask the questions. So I guess everything was clear. In that case, I would like to thank you all very much for attending this webinar, and looking forward to see you again in a few weeks, where we'll be hosting the next webinar. All of you who attended will get a recording of this webinar. Also, the people who did not attend but who registered. And if you ever want to learn about more webinars, they are all here on our webpage under the Learn webinar. Okay. It's kind of hard to click because I have this GoToWebinar thing going on. And so here is the list of webinars. If you sign in, you get the view webinar option. So once again, thank you for attending our webinar, and see you again soon. Happy 3D surveying, and bye-bye.